So again, we're doing abbreviated electron configurations, continue on page 43, so same objective. So now, when we do abbreviations, one of the benefits is we can kind of be lazy, but then also it avoids us making small mistakes, right? So you can use this to help you determine the distribution in electrons among the energy levels, sublevels, and those orbitals a little bit more quickly while still meeting all of those expectations, okay? So then, you guys remember us looking at this yesterday. What are these first two rows called? Or sorry, what are these first two columns called? S-block. S-block, so anything in there is going to end in what sublevel? S. Over on the right-hand side, we've got the P block. Everything over here is going to end in a P. So we're going to use that to our advantage. Then we've got the center here, which is which block? Which is weird in that what happens to its energy level? The D goes down 1, and then the F goes down by how many? 2. Okay? So those are going to be key things for whenever we're doing noble gas configurations. So let's work those. I'm going to start by doing regular electron configurations, and I'm just going to go quick because I want you guys to see this that I think I highlighted yesterday pretty well. Okay? So we've got neon, bless you. Neon has 10 electrons, so that's going to be 1s2, 2s2, 2p6 for my electron configuration here. Then I've got argon, which is going to be 18 electrons, which is 1s2, 2s2, 2p6, 3s2, 3p6. Krypton is 36 electrons, so that's 1s2, 2s2, 2p6, 3s2, 3p6. Go up to 4s2, back down to 3d10, and up to 4p6. What are you guys noticing that I'm doing every time I'm going through these configurations? There's a P at the end of every one of them.
And the P is full.
The P is always full, okay? And then what do we notice about the starting of it?
1s.
1s. Yeah, we're all starting the same way every time. So what we do for a noble gas configuration is we say, okay, well, let's use neon equals this. Let's use that argon equals this, and that krypton equals this, and substitute that in for all of the other elements so I'm not having to rewrite that every single time. Okay, so for example, to cut out a bunch of my neon, I could go and say, okay, well, xenon has 54 electrons, but instead of doing the first 36 electrons, I'm going to say, hey, let me just use krypton's electron configuration here, right, Kr, and then continue on from krypton. So I ended with 4p6, so then I go on to what after 4p6, which is going to be 5s2, and then continue on until I get up to the 54 electrons. So 5s2 would go then to 4... No. Yeah, 4d10, 5p6 would be my noble gas configuration for xenon. Okay? Yes?
So, do you do that every time? Do you just take an element and then apply it? Or is there like a specific way you're supposed to do that?
Are you asking which one of these to know?
Yes.
It's got to be a noble gas. Always a noble gas.
So you take another noble gas and apply it.
So anything in the right side.
Right. Any group 18, you're going to use the biggest one because that means that you can abbreviate the most of it. Right?
Okay.
The biggest one that still fits in that electron configuration. So looking at radon, that's going to be how many electrons for radon? 86. I'm going to look at the next largest noble gas, which in this case is xenon. I'm going to put square brackets and write Xe to say, hey, just go reference the electron configuration for xenon if you need to know those inside ones. Sorry. Convention is that you do square brackets, yeah. And then after xenon's 4p6, the next one would be 6s2. Then after 6s2 is the F, but that drops back twice, so 4f would be 14. Then 5d 10 and 6p 6. Can you guys imagine a couple of days ago trying to do an electron configuration with 86 electrons? Gosh. Oh man, do you guys see how much easier this is to use the noble gases kind of as your milestone and then just continue on from there?
I see how it's easier, but it's not going to be easier for me.
Well, it is once we practice it. Again, the reality is it never gets easier. It's just that you guys get better as we practice.
No, the thing is,
You learn to remember
it's the numbers. Like when I write down the element, the noble gas, like I don't know what comes after.
I'm going to teach you that. I have not taught you this yet. I'm just showing you what it's going to end up looking like. The next couple of examples, I'm going to actually show you how to go through that. Okay? So, let's look at sodium. You guys find sodium on your periodic table. While you guys are finding sodium, I'm going to write the normal electron configuration out. Sodium is 11 electrons, so that's 1s2, 2s2, 2p6, 3s1. Okay? Once you find sodium, put your finger on it, please. Your periodic table. You guys are putting your finger on sodium. Atomic number 11. Yes. Yes. All right, we've got then sodium right there. You're going to go to the last noble gas before sodium. So if sodium is 11 electrons, you're going to go find whatever noble gas was just before that. So neon is just before sodium. So we're going to write neon. How many electrons does neon have? So that's going to be replacing all of that right there. So this is going to be built up in that. So then the next thing is we're going to look. This is just how I do it because this is what makes sense in my brain. Okay? So eyes on the board. We've got this neon right here. You're going to go down to the next one. What block is this going to be? S block, what energy level? 3. So then 3s. You guys already told me that neon takes care of how many electrons? 11. I'm sorry. Takes care of 10, which means that I only need one more. So 3s1. Okay. What questions do you guys have on how I did that? So this whole thing is Na.
But you're substituting in, so you don't have to write the 1s.
Right. So this Ne is that right there, the 1s2, 2s2, 2p6. Need me to try to explain that a little different? Okay, let me explain this next one, and if you're still having questions, let me know, okay? All right, magnesium then. Magnesium has 12 electrons. Got that right there. I need to go back to the last noble gas before it, which again is neon. So I'm going to write Mg is neon's electron configuration plus, go down to the next spot here. That's my S block. It's in the third energy level, so 3s. Neon has 10 electrons. I need 2 more, so that's going to be 3s2. John.
So, for the noble gases, could you just put the noble gas and then count that as like?
So you want to go back to the last noble gas because you want to be actually showing the valence electrons. So that's
You can't just do like krypton and then say krypton.
so that's where it's like kind of correct, but it's unhelpful because you don't actually see the valence electrons.
Yeah, like krypton is krypton. It's not helpful.
Right, exactly. Yep. It'd be like defining prestidigitation with prestidigitation. It's like, well, then I don't know what the word means, then I wouldn't have been looking up in the dictionary prestidigitation if I already knew what it meant.
Yeah.
So, great question. All right, what other questions do you guys have? Yes.
Okay, so you're trying to find magnesium, right?
Right, yes.
So neon is just like a placeholder?
Exactly.
Okay.
Yes, that's exactly what that is. Bless you, bless you. Instead of having to write out 1s2, 2s2, 2p6 every single time, or like whenever we get down to ones that are going to use xenon and stuff like that, instead of writing out all of those 54 or 86 electrons, you can just say, hey, just go look at the first 54 for xenon, and then let's start from there. Solid questions again. Thank you guys very much. Alex, you had a question?
I did. So, like, so after you put a noble gas down, you just do it by the energy level and the sub level? Like to begin?
Like what you go next to?
Yeah.
Yes. Yeah, if I'm understanding your question correctly. So, like, let's look at a couple more. We've got carbon. How many electrons for carbon, Colin? Will you find it for me? For carbon?
6.
Awesome. So then I need 6 electrons. And the noble gas that came right before carbon is going to be what, Tyrese? What's the noble gas before carbon? Remember, which group are noble gases? Group 18. So it's only, you can only use group 18 elements. So helium would be the noble gas before carbon.
Okay, I get that now.
Okay, so which one for carbon? Helium. Now that only saves me 2 electrons, but it's still, I don't have to write those 2. Then go down. That next block is the S block, second energy level. So what's the next sub-level I'm going to write here? Not 3S, it is going to be an S. 2S, yes. 2S. The helium counts for 2 electrons. I can put 2 electrons here. And then, right, Destiny.
What if you don't want to do it this way? Do you have a choice?
So if I specifically ask for abbreviated, then I need you to be able to do that. If I don't specify, then you could do the whole thing.
It looks like this cool complicated.
It's really not.
Like, you're more
Once you practice, I think it'll start to click into place.
It's really, really simple.
Oh, what did I do wrong?
Confused on is like starting after like you.
That's your chisel. You're not supposed to fill them up.
Right. What do I need to do for the 2P?
Only put two.
Yes.
That's it.
And you guys already told me that. 2P6. I'm sorry, 2P2. I changed it and then still said the wrong thing. All right.
It now has 100 neutrons. I mean, not protons.
So we've got calcium then. Calcium should be 20 electrons. Noble gas before calcium is going to be what? Tyson? AR. So I'm going to do AR, and how many electrons does that account for? 18. If it is helpful, I often will go ahead and write how many electrons it takes care of so that I know that that's where I'm going. Okay? If this is a confusing way to do it, you guys call me over to you when you guys are doing practice, okay? Next is going to be an S. What sublevel? I'm sorry, what energy level is the next one going to fill up? Harley? 4, so it'll be a 4S. 18 only needs 2 more to get to 20, so 4S2. Remember, finding protons, neutrons, and electrons was confusing for you guys too when you started out. How are you guys feeling about that now?
Wow.
Yeah, you guys have practiced a bunch, and so that is a lot more consistent for you. Yes, sir.
So after you write down the element, it goes is the sublevel an S?
The sublevel is always going to be an S when you go to the next energy level, yes. Do you guys catch that?
So the S is the very first thing you write,
Right, you're always going to have an S as the first thing.
and then you write the energy level, and then you write the two or
Right, however many you need, yes. So then let's do titanium real quick. Titanium is going to be 22 electrons. John, I'll get you in just a moment, okay? Titanium is going to go back to argon also. That'll again be 18 electrons. Give us 4s2.
I thought it would be 4D.
So
What the?
Look up your, we
Here it goes.
configured, argon earlier, and the last one we did was 3P6.
It's in the D bowl.
yeah, so you have to go through that 4s first though. So you'll fill up the 4s, just like on a configuration table. You'd get to 4s before you get to the D. Okay, so that's my fault. 22 electrons, argon, 4s2, that is 18 electrons. Then 3D, I'll need 2 electrons there. Questions? Okay. You guys want to try zinc on your own and then we'll check it? Good. I love the enthusiasm. You guys check. Go ahead and do zinc. Zinc will end up being back to argon. That counts for 18. Then 4s2, 3d, 10. Awesome. Questions on that?
None.
All right, cool. Then,
You want us to try silver?
nope, we're going to go ahead and jump over to here. You need to be able to identify which element or which ion could be represented by these. Okay?
Whoa,
That's
oh,
hilarious.
that's
2 minutes, do the first three. 2 minutes, do the first three. Which element or which ion could that be? He2S2. What element is that going to be, Lane?
Oh, the first one?
Mm-hmm.
That's gonna be Berlin. Berlin.
Beryllium.
Berlin.
Beryllium.
Like the Berlin.
Guys,
I can't pronounce it.
we've got any 3S2, 3P6. What element is that going to be? Caitlin? Awesome. It will be aluminum. Then we've got. Did you guys have questions on that? Alex?
I think you said 3P6 again.
Oh, I probably did. I apologize. 3P1.
What?
Ne3S2, 3P1. Then AR4S2, 3D5 is going to be what, Harley? TC. Okay, questions on any of those?
Why can't you just say the element, Harley?
Cause I don't know the name of them.
Okay, so again, just like yesterday, you need to be able to do the abbreviated noble gas configuration for any element and then also be able to do that backwards. Okay,